In the last video, we used this differential equation, dy dx equal to x minus 5 over y squared. And then we got the solution to be y is equal to 3/2 x squared minus 15x plus c to the 1/3. I now want to talk about how to go backwards. If we have a function like this y equal to 3/2 x squared minus 15x plus c to the 1/3, how do we show that it actually satisfies this differential equation? So if I give you a random function, how can you tell me if it is a solution? Well, when I look at this differential equation, the left-hand side has the dy dx. So let's start with that. What is dy dx? Well, I need to take the derivative. Power rule says I need to bring the exponent down and subtract by 1. So I have 1/3 times 3/2 x squared minus 15x plus c to the negative 2/3. And then the chain rule says I then need to multiply by the derivative of the inside. The derivative of 3/2 x squared would be 3x, the derivative of negative 15x would be negative 15, and the derivative of c is 0. I now want to simplify this. I'm going to go ahead and write it as an actual fraction, moving my negative exponents to the bottom. That would give me 3x minus 15 is equal to 3 over 3/2 x squared minus 15x plus c to the 2/3. I'm now going to use a little bit of algebra. I'm going to factor the top, and then I'm going to rewrite my exponent on the denominator. When I factor the top, I get 3 times x minus 5. On the bottom, I have 3 times, and then I rewrote the exponent as 3/2 x squared minus 15x plus c to the 1/3 squared. Since raising a power to a power, I multiply, and 1/3 times 2 is 2/3. But now this is a lot easier to see. In particular, this thing right here is exactly the same as y, so I can replace that with just a y. That gives me 3 times x minus 5 over 3y squared. We can see that our 3's cancel, which gives us x minus 5 over y squared, which is exactly what we claimed it was at the beginning. So this is how we actually show that a solution actually satisfies a differential equation. Try to actually plug it in. Plug it into one side and show that you get the right-hand side whenever you simplify.